Pictured here is what a PLC looks like. A small square computing device controls machines and has a bunch of LED lights. Think about the fact that a PLC, or PLC-like device, is controlling it. Next time you look at all of the machines in a manufacturing plant, know that each one probably has a PLC inside of it controlling the machine, being the brains of the operation. Everything in the PLC is ones and zeros, on and off, etc., like switches that are on or off. A lot about the PLC and working with it can be simplified down to that same level. 1 or 0, on or off, true or false. We could go on about that PLC stands for Programmable Logic Controller and all, but everyone refers to them as PLC. So for this webinar purpose, you do not need to memorize acronyms. As long as when we're done, if someone mentions PLC to you, you know what that person is referring to. Person in control uses sense of sight to determine room is dark, so turns on light. The person's eye is a sensor input, and their brain the controller making the decision, and their finger output action of flipping on light. The smart sensor is very limited in the decisions it can make, unlike the human doing the same job. Also important to note, if we wanted to add conditions, it would take hard wiring and possible replacement of sensor control to modify control. So, greater time and cost will result than if a PLC were used to control the light. The PLC, just like the human, 1. Looks at inputs for sensors, then 2. Makes a decision based on preset conditions it is programmed to look for, then 3. Tells the output to energize and turn on the light. After step 3, it restarts the 3 steps over in a continuous cycle, loop. This is called a scan cycle. The advantages of a PLC over a human? The PLC frees up human time and is more reliable. Equally advantageous is when process changes or is improved. No rewiring or retraining of all humans in a building, manufacturing plant, or society.